Elementary statistics, practice test number 2, covering module 2, chapters 4 and 5. Chapter 4, probability. Chapter 5, discrete probability distributions. We look at a few definitions, a simple event and a sample space. A simple event is an outcome or an event that cannot be further broken down into simpler components. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive or disjoint, the probability that both will occur is 0. Here's the definition. Events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. There is no intersection between the two. Probability of A intersection B, we write it in this format or in this format, is equal to 0 because A intersection B is an empty set. Intersection of A and B is an empty set. This is phi representing an empty set. The probability of event is always between 0 and 1. Can it be negative? No. Can it be larger than 1? No. What you want to pay attention to, the only time that it goes above 1 if it happens due to round of error, meaning it might go to 1 point, a bunch of zeros, 1.000001, something like that, or close to 1, like 0.9999. It could happen, and it is a correct probability just because of the round of error. Otherwise, it must be identical to number 1, the maximum that it could have. The sum of the probabilities, it's always 1. They must add up to 1. They must add up to 1. Just to explain the concept, let's look at this experiment of rolling a die. A regular die is 6-sided, and we have the sample space of 1, 2, 3, 4, 5, and 6. A simple event would be an individual number such as 1, 5, you name it. A compound event would be any event having more than one outcome. An example, if you are interested in getting odd numbers, that would be 1, 3, 5, and that's an example of a compound event. We want to answer the following question. The number of combinations of n items selected n at a time is, we use the following formula, n factorial over r factorial, n minus r factorial. We're looking at combination. And so in this case, both n and r are n. And we go through that. This n minus n factorial is 0 factorial, which is equal to 1. So this is equal to 1. They cancel each other. We end up with 1. What about the permutation? The formula for the permutation, NPR is n factorial over n minus r factorial. So let's replace it by having r equal to 0. This is obviously n factorial, and therefore the ratio of the two is 1. Needless to say, when you're calculating this stuff, you can ultimately use a calculator, but it is important as a part of the partial credit, if you want to show work, justify the answer. For example, in this case, Preston, could you read this question?
Yes. 2C, a pizza parlor offers 10 different toppings. How many 4-topping pizzas, different toppings, are possible?
Excellent. First, notice order is or is not important. And the reason it's not important because you're ordering pizza and you want 4 toppings. In what order are you going to ask for the toppings is not going to be important. So it becomes a combination. And here's the formula for the combination that was given to you. You start with that. If we were to do this by hand, I can show you quickly, but in general, what matters is that understand this part and why we use combination, understand this part, and then you can even use a calculator. And this becomes 210. If you were to do this completely by hand, by the way, it would be something like this. You are going to replace the top with 10, 9, 8, 7, and you stop at 6 factorial because this is the larger of the two in the denominator between 4 and 6 factorial. Now 4 factorial is 4 times 3 times 2 times 1. And again, if you were to do this by hand, number 4 times number 2 equals number 8. Then in the denominator, the only number left is number 3. So number 3 is out. Number 9 changes to 3. 10 times 3 times 7 is 210. Nobody expects you to do this by hand, but if by any chance you had to, it is really not that difficult.
How many 6-letter code words can be made from the 26 letters of the alphabet if no letter can be used more than once in the code word?
Again, what happens with the order is important or it's not. You're dealing with a code word, and order is important because AB would have a different meaning than BA if you're coming with a password, let's say. Therefore, we use a permutation and the formula as follows. Again, as long as you show this one, order is important, and you show this one, again, you can go with the calculator, finish the job. I wouldn't worry about the rest. The rest is basic math, but the justification as to why you're using that makes a huge difference. A quiz consists of 3 true-false questions. How many possible answer keys are there? Write out the sample space and tree diagram. Well, the general formula, N of S, the sample size, is the number of outcomes per stage. And then you raise it to the power of number of stages. For example, in this case, we have how many outcomes per stage. We have a true, false. We have only 2 outcomes, either true or false. How many stages? That's the number of questions. Therefore, it's 2 cubed, which is equal to 8. If we were to do the sample space in this manner, and it's manageable because we have only 3. So look at the stages here. Stage 1, we have true and false, done. Stage 2, if you look at this tree diagram, for this T, we have 2 branches. For this F, we have 2 branches, resulting in 4. This is the result of the second stage. And then for this T, we have 2 outcomes. For this one, 2, the same thing here. And this would be the final stage. And if we were to write the sample space in this branch, we would write T, T, T. Then the next one would be T, T, F. T, F, T, T, F, F. Continue with the rest of them, and you get 2 cubed or 8 outcomes. Now we are tossing 5 coins, and we want to see how many outcomes. We are using the same formula, number of outcomes per stage. We have only 2 outcomes because it's heads or tails. 2. And how many stages? We have 5 coins. 2 to the power of 5 results in 32. 2 to the power of 5. Be very careful. It's not 5 squared, it's 2 to the power of 5. 5 squared is a different number, it's 25. So 2 to the power of 5, 32 outcomes. If you were to write the sample space, I want to explain 2 things. The very first one, all of them heads. Notice there are 5 of them. The very last one, all of them tails. There is not enough room to show it here. And I'm going to show with 4 coins how the tree diagram works. If you look at all the stages, take a look at this stage. The first stage for 4 coins only. So this repeats stage 1, Stage 2 and stage 3 is pretty much similar to what we did in the previous page. Heads and tails, or true or false. That really makes no difference. Here's the fourth one, the fourth stage. Now I need one more stage for the last one. So for this one, for example, and be consistent. If the top branch is H, the bottom is T, you keep it that way. This one, the same thing, H and T, and you're going to continue all the way down. And you see the very top branch, all of them H, H, H. There are 4 of them. Then there is one more that I put in, total of 5. And the next one would be H, 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 T. If you look at the last one, T, 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 and there would be one more. That's how you come up with the answer. Again, not easy to show when you have more than really 3.
A random sample of 100 people was asked if they were for or against the tax increase on rich people. Of 60 males, 45 were in favor. Of all females, 22 were in favor. Write the contingency table and answer the following questions. If one person is selected at random, find the probability that A, this person favors the tax increase on rich people.
So the most important part is to be able to come up with the contingency table accordingly. So male, we're going to use M, female, we're going to use F, just to make it easy when we want to write the probability. For tax increase, T for tax, against, A for against, just to give you an idea. Now we need to fill up what we have, a random sample of 100 people. That means total is 100. So right here is total. Total of everything is 100. Was asked if they were for or against tax increase of 60 males. So M, that means you put 60 here. 45 are in favor, you put it here. Of all females, we don't have a number yet, all females. 22 were in favor, we put the 22 here. So those are the numbers that are given. Now, what about the rest? So take a look. For example, if I want this one, I add these 2 numbers. So 45 and 22 gives me 67. So now that I have 67 here, this number would be 100 minus 67, which gives me 33. This is 60, this is 100. They add up to 100, so this must be 40. This is 60, this is 45. This number must be 60 minus 45, which is 15. So you can easily fill up everything in this manner. So the very first thing is to come up with this table accordingly. This person favors the tax increase on the rich people. So we are looking at the probability, and therefore we write the formula. I hope you remember that in general, probability of an event A is N of A over N of S, the sample space. So N of T over N of S, that is 67 out of 100. Now, if you are writing it as a decimal, so be it. If you're writing it as a fraction, so be it. If you have a fraction, you must do the reduction always. In math, we reduce fractions. They don't even have to ask us. Generally speaking, a fraction is a perfect answer. If they ask you for decimals, follow the number of decimals. Now, this person is a female, so we stick with the general formula. So P of F is N of F over N of S, which means 40 out of 100. This is what matters, okay? And where the numbers come from, of course, reduction is important. The final answer, you can say 2/5 or 0.4. This person opposes a tax increase on rich people, given that the person is a female. So the key word is the given, which makes it a conditional probability. By definition, probability of A given B is probability of A intersection B over probability of B. Probability of B given A is the probability of A intersection B over P of A. Now, this type of question can be done without going through the formula if you understand the concept. And here's what I want to explain. The moment you see given, the total sample space of 100 is gone and it's now smaller. So right after given that the person is a female, that is your sample space, your new sample space. That means your new sample space only has 40 members or subjects. That means that's the denominator. Out of those 40, so this is the group you're dealing with, given, so you know you're for sure you're dealing with females. This person opposes the tax increase. So we are here, the denominator is 40. What is the numerator? Against 18 out of 40. Or we can stick with the formula. Probability of A given F is probability of A intersection F over P of F, or N of A intersection F over N of F, which gives you obviously the same result. But understanding the concept of the given, you can go directly to the table and pick up the answer. As always, reduction. This person is a male, given that he favors the tax increase on rich people. Again, if we want to go with that, right after given, favors. Okay, how many are for it? Total of 67. After given, this is the new sample space. Your denominator is 67. Out of those 67, how many happen to be males? And that would be the answer for the numerator. Or we stick with the formula. Probability of M given T is probability of M intersection T over P of T, N of M intersection T over N of T. Do the math. And you do the simplification if you can. If you cannot, you leave it like that. If you want to go with the decimals, however many that they ask, to be on the safe side, you want to carry a lot of decimals to be on the safe side. We are looking at the same question. The next part is asking this person is a female and favors the tax increase. Before we move on, it's important to know the only time your sample space is not the total of 100 is when you see given. If given is not there, you go back to this total sample space of 100. With the given, which is a condition of probability, the total sample space decreases. So with that being the case, you already know this is the case. So this person is a female and favors the tax increase. So you come up with the two groups like this: females, tax increase. The intersection is number 22, so 22 over 100. This person opposes the tax increase on rich people or is a female. So let's write the union of events. I hope you remember that. In this case, specifically for this one, probability of A or F with the symbolic format. Probability of A plus probability of F minus probability of A intersection F. The reason is because the intersection accounts for two times, once for A, once for F, therefore we take it out. So with that being the case, N of A, so you find the A, total is 33. N of F, you find the F, total of 40. You add them up, but remember, what is their intersection that has been accounted for two times, and you have to take it out. 18 is a part of both. Therefore, you take it out, and the answer is 11 over 20. 55 over 100 must be reduced to 11 over 20. Are the events females and opposes the tax increase on rich people independent? Explain. The definition of independency is as follows. Let me just write this definition. Events females and opposes the tax increase on rich people are dependent because the occurrence of one of the events does affect the other. Now, this is the definition, but it's very vague and it's hard to follow. Therefore, we stick with the definition of mathematical definition of the same topic, which has formulas. Probability of A intersection B, if you look at this one and you do the cross product, becomes probability of A given B times probability of B. If you look at this one and you do the cross product, probability of A times the probability of B given A. If the two events are independent, probability of A given B becomes probability of A. Probability of B given A becomes the probability of A. And simply is the probability of A times B, if independent, Therefore, you look at probability of A given F in this example, or F given A. I leave it for you to look at that later on. If that's equal to probability of A, they are independent. But they are not. See, probability of A given F. So take a look at F, 40. How many A's? 18. So 18 over 40. I didn't even bother to reduce because I'm checking to see if it's equal to probability of A. The denominator is 100. A would be 33. These two numbers are not equal. Therefore, they are not independent. Independency means conditional probability. Probability of A given F is equal to marginal probability of A. They are not independent. Are they mutually exclusive? Again, as far as the explanation is concerned, they are not mutually exclusive because a person can be both female and oppose the tax increase on rich people. Let's do it mathematically with numbers. Here's the proof numerically. What is the probability of A intersection F? 18 over 100. You don't even have to reduce that. This is not equal to 0. If this is 0, they are mutually exclusive. But it's not. You just proved mathematically they are not. We want to find the probability of getting the outcome of tails and 2 when a coin is tossed and a die is rolled. Now, definitely independent events. Probability of A intersection B is probability of A times the probability of B when they are independent. And so, probability of tails times the probability of a number. This one would be 1 out of 2. This one, you're dealing with a regular die. That's the assumption. So 1 out of 6 for any number, including number 2. The result is 1 over 12. Again, I hope you realize if you want to change this to a decimal, you have to pick up a bunch of decimals to be on the safe side. A classic counting problem is to determine the number of different ways that the letter of personnel can be arranged. Find the number. First, a quick reminder. Permutation rule, distinguishable permutation. When some items are identical to others, the number of different permutations or their counts, when n items are available and all n of them are selected without replacement, but some of the items are identical to others, is found as follows. N1 are alike, N2 are alike, so on and so forth. This is the formula. So let's see what we have here. We're going to write out the N, that means how many letters we have, which is obviously 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, that's N. Then we see P, there is 1 of them, E, there are 2 of them, so on and so forth. Now plug it into this formula. And as you can see, all of them are 1 factorials except this 2. This is 2 factorial, 2 times 2. So the denominator is simply number 4. And again, you can use a calculator for that, obviously, and you come up with the answer. A box consists of 14 red and 36 blue markers. We select 3 different markers. What is the probability that they are all red under the condition with replacement? Well, it's just a simple probability of n of r over n of s. For each case, as far as the red is concerned, we have 14 over a total of 14 plus 36. So 14 over 50. Now, this is a simplification, reduction of fraction, and this is a decimal representation. So because it's with replacement, they are independent. That 0.28 repeats for the next one and the next one and the next one. So we want 3 of them. If we were to write the formulas, probability of R sub 1 intersection, R sub 2 intersection, R sub 3, by the fact that they are independent, you just multiply each one as each one is equal to 0.28, and it becomes 0.28 cubed, or 7/25 cubed. If they ask you for an approximation to so many decimals, you follow that. If it's a fraction and they want it in the form of a fraction, you cube number 7, you cube number 25, and you have the answer. In the next part, it's asking for the same question except without a replacement. And what really matters is to understand, because it's without replacement, whatever the first one is not changing. It is still 7/25 for the red. But when we go to the next stage, first and foremost, the total of 50 is no longer there, it's 49. And the numerator for the red goes down by 1, and it keeps on doing it in the same manner. So with that being the case, probability of 3 red is probability of R sub 3 given that R1 intersection R2, this is R2. And it's important to see the first one is the same. And I'm not going to do the reduction on purpose because I want you to see what happens to the next one. The denominator goes down by 1. The numerator goes down by 1. Same thing here. The denominator goes down by 1. The numerator goes down by 1. Because we are looking at the red, and it really depends on what happened in the first stage. Again, you can multiply the top, the bottom if you want it in the fractional form. And reduction gives you that, because obviously you can see 14 and 49 cancel each other. This gives you 2, this gives you 7. 12 and 48 cancel each other, 1 and 4. And then there's one more number that you can cancel because this was 2 with 48, and you come up with 13/700 precisely. It's very simple. Do the reduction of these fractions. Again, as an example, it's easier to see. This is 2, this is 7, this is 1, this is 4, and take it from there to, do this again, but 2 and 50 is 1 and 25, do the math, 1, and then 25 times 4, 100 times 7 is 700. The top has all ones except number 30. So that's how you do that, even if you were to reduce the fractions. The second method is P of R red, is N of R red over N of S. N of R red over N of S. N of S, it's a combination because order is not important. Combination of 50/3. And out of those, how many reds do you want? You want 3 out of how many? Out of 14 reds. You can try this and you'll see you end up with the same answer. As far as the tree diagram, and that's extremely important. Again, look at the first stage. Second stage. If this is red, keep the top one red. So 14 goes down to 13, 50 goes down to 49. Notice in the second stage, the denominator is 49 for each and every one of them. For example, the probability of blue is still 36 blue left, so 36/49. If the probability of winning the race is 5 out of 12, what is the probability of losing? We are looking at complementary event probability of A complement or A naught or A bar is 1 minus P of A by definition. So if probability of, let's say, W standing for the winning is 5/12, then probability of losing is 1 minus that, and we end up with 7/12. I hope everybody's comfortable with fractions because 1 is 12/12. What are odds against winning? By definition, the probability, the actual odds against an event is defined as probability of its complement over itself, probability of itself. So with that being the case, this is odds against. So odds for losing or against winning, these two notations I'm using because they both mean the same thing. Odds against winning, so W with the bar, or odds for losing would be probability of losing over the probability of winning. So we write those numbers, 7 over 12, 5 over 12. Please understand this is important. And that is a complex fraction. 12 and 12 cancel each other, 7 to 5. You write it as a ratio of two integers. So you can leave it like that, or you can leave it like that, but do not change it to any decimals or anything like that. 7 to 5. That's how it is reported. The payoff odds for this question is 6 to 1. How much profit do you make if you bet $10 and you win? The definition of a payoff odds against event A is as follows. Payoff odds against event A is the net profit over the amount of bet. So look at this fraction and do the cross product. Net profit would be this times this. So net profit would be the payoff odds times the amount of bet. The payoff odds happen to be 6 to 1. That means 6 times 10. Let's make sure everybody understands how we arrive at this one. Let's say it was 7 to 2, then 7 to 2, that means 3.5. Whatever this one is, this is a ratio. This is a fraction in essence. So we don't want to mix up anything.
When two different people are randomly selected from those in your class, find the indicated probability. Assume birthdays occur on the same day of the week with equal frequencies. A, probability that two people are born on the same day of the week. B, probability that two people are both born on Monday.
When we want two people born on the same day, then we don't specify a day. So the first person can be born on any day. What matters is that the second person must be born on the same day. So the probability that that second person born on the same day is 1 out of 7. And so basically that's it. The first one, it really is 7 out of 7. Any day will do the job. Any day will do the job. It is the second one that must be identical, 1 out of 7. Their product is 1 out of 7. However, if you look at the case where we have two people and we want them to be born on the same day, for example, Monday, now each one has a probability of 1 out of 7. The first person being born on a specific day, for example, Monday. Same thing for the second person, for example, Monday. Now their product is 1 out of 49. How many different other license plates are possible if the plate has 2 letters followed by 4 numbers? So what is important is to really understand this accounting problem. So we have how many spots? 6, 1, 2, 3, 4, 5, 6 in general. 2 letters. So we have 26 letters. I don't see any restrictions. So we can have 26 here. We have 26 here. Then 4 numbers. Remember, the numbers are from 0 to 9. That means 10 digits. So I can put 10 here and I can repeat it because there is no restriction. So the answer is 26 squared times 10 to the power of 4. Needless to say, calculator will give you the answer. I'm interested in the justification using this methodology. The next one says, now we want 3 letters. We can't repeat. So let's stick with that. 1, 2, 3. So I can put 26 here, but now I got to go down to 25 and then 24. Followed by 3 numbers. There is no restriction, so I can have all 10s. So 26, 25, 24 times 10 cubed. Now we have 4 letters. Repetition is okay. That means I can have 26 and 26, 26, 4 of it. So 26 to the power of 4. What about the next 2? Those are 2 numbers. We can't repeat. So I can have 10 here, but then it goes down to 9. Now 4 places, each character is either a letter or a number. Well, we have how many letters? 26. How many numbers? 0 to 9, 10. So we have total of 36 alphanumeric characters. And we have How many spots? 4. 1, 2, 3, 4. Only 4. So 36 to the power of 4. So take a look. We have total of 36 characters. We have only 4 spots, and we can fill up 36 in each and every one of them, no restrictions. The answer is 36 to the power of 4. In a first grade school class, there are 10 girls and 8 boys. In how many ways can the students finish first, second, and third in a foot race? Assume no ties. It's important to pay attention to what's happening, whether order is important or not. In how many ways can the students, so generally speaking, we have how many? N is 10 plus 8, 18 students. Because we are looking at first, second, and third, order is important, becomes a permutation. So permutation of 18, choose 3. Now 18, choose 3, you can go with that. Or you can go with a calculator methodology. I have the command here, 18 NPR. So first you put number 18, then you look for NPR, and then put number 3, gives you the answer. So to get there, you go press math and then select probability, and then we'll come up with the answer. Here's the next one. The girls finish first and second in a geography contest. Assume no ties. Again, we are looking at how many, what is our N? Is order important or not? Order is important because we want the first and second. And because we are looking at girls and girls only, N would be 10. So N is 10, and we want the first and second. So 2 places. Three boys be selected for launch duty. That means right away we go here and we look at the N being 8, and order is not important. We are not specifying anything, so it's a combination. N choose R, 8 choose 3, come up with the answer. This is what matters, understanding that it is a combination. The rest is very simple to calculate. 6 students be selected for a team, hockey team. So we have total of 18 students, and we want to choose 6 of them. It's a combination because order is not important. So combination of 18, choose 6. Now the rest is not important. You can use technology or do it by hand. And I'm showing you the result by hand, result by technology. Either way is fine. What matters is that you understand the justification as to why we do that. We want to choose 5 students. How? We want 3 boys, 2 girls. So from boys, 8, we want to choose 3. There is no, order is not important. There is no specification as to how, becomes a combination. 2 girls, so how many? 10, N is 10, choose 2, and then you multiply the 2. So combination is in order. Combination of 8, choose 3 for boys. Combination of 10, choose 2 for girls. Their product would be the answer. 25, 20. Again, when you write this, after that, you can do it with technology or otherwise. 4 girls we selected for a field trip. So we go back, N is 10, we want 4. Order is not important. It's a combination. Therefore, C, 10, 4. Again, technology or by hand makes no difference.